the Python notebook so that we have these snapshots. So I'm going to use today's. And let's see, for today, the plan is, okay, while that starts up, hopefully nothing messes up. So let's quickly just run through what we did, and then I did clean this up a little bit. So if you want to download it again, well, I cleaned it up like last week after class, so tidy up the headers and so that you know what we're doing. And then again, when we first loaded up, it just started up the Python interpreter. Nothing has been executed. It's a blank slate in the computer's mind, if you will, right? So if you want to get back to where we were, you really need to start running everything from the beginning. So you can do run all to basically load the data from the files again. Because now if you try to run something here, it's going to give you an error because copy data has not been initialized. All right, so it's going to give you a bunch of errors. So you do have to sort of get everything back up to speed by doing run all. All right, and that could take a while. So last time we went through basically very basic Python. We mainly looked at one data structure, which is lists or arrays, right? And then we did how to loop over that, right? So writing for loops, and then we tried to find the average, and then we figure out that hey, average might be something that you want to use over and over again. So good to put it into a function. So define functions. And then the only thing I added is I created another version of the function where I added another input variable called column, so I can select the column that I want to compute the average on. Okay, so that's pretty much where we are, right? What I would like to do, hey Jasper, what I would like to do really quickly right now, right, is think of it as almost like a test, if you will. Take maybe 5 or 10 minutes. I don't think it's hard. Write a function right here, right now, to calculate the variance of a given column in the data set. Okay, you guys remember how variance is defined? If not, feel free to look up Wikipedia. I'm just looking for correct code. It doesn't have to be the most efficient algorithm. All right. So you can just basically implement this formula, which is basically, if I would just sort of explain it, right? So it's a bit like finding the average, but now I actually need the average, right? So I'm going to loop through all the values of that column, subtract the average from each value, right? And then square that, and then add that to the total. And once I finish looping through it, I would divide it by the total number of elements and return that number, and that would be your variance. Okay, so that's the straightforward definition of the variance. Okay, let's try that. So you can just cut and paste from the previous average, I mean the code for finding the average, and then just modify from there. Okay, so just a quick practice for you guys. And I might walk around. Just to maybe 5 minutes for that. Okay. Okay. So I guess first question is, do you understand variance or the operational meaning of variance?
Is there?
I think that's the first thing. Because if you do not have a good understanding of that, so maybe let me Just make sure, right? I know it's low dot, right? But remember, finding the average is basically finding, well, from a statistical point of view, is finding the mean, right? Which notation-wise is often written as square bracket as EX, right? But operationally, this is represented as a summation if if uh, if if I have n values of x, right? If I have n values of x, right? X1, x2, x3, xn. If I have n values of x, then I'm summing this. Right? So the operation definition is this, and again, so there's a bit of a translation that you need to do, right? Because this is mathematical symbol, right? And we would then translate this into a for loop, right? Which is what we did the last time, right? With basically this, right? I'm finding, and I assume that I'm finding the average of column, the second column, okay, which is 1 because you start from 0, so 0 and 1, right? So I'm summing. I set my total to 0. I loop through all the data, right? Grab the second column, add it to sum, all right? And count is just counting the number of elements, right? And then I'm going to return total divided by count, right? So this for loop is sort of operationalizing this, right? This for loop is how you implement this. So another way to think of it is that you kind of have to build this translation, right? Whenever I see a summation sign, that's just a for loop, right? So it's almost automatic to get to that point, right? Variance, often represented by sigma square, is as this thing shows, it's actually the expected value of x minus mu squared. Right? Again, if these notations are scaring you, don't worry, it's just notation. It's just notation, right? And this, again, it's equivalent to this. Right? And you basically you have x here, so it's kind of, you have the same thing here, it's just x I minus mu squared. All right, and this is constant with respect to the summation or with respect to the for loop. Hence, this needs to be computed outside of the for loop, ideally. All right, so this is the same as this. If you didn't make a connection. All right, that's the same as that. All right. So very similar, in a very similar way, you implement it the same way, right? You would actually take this. You can take this same for loop. The difference now is that instead of summing xi, I need to have xi minus the average. So you need to find the average first, right? Put it into a variable, right? And then parenthesis the whole thing. The easy way to square is just to multiply by itself. Okay, and pretty much the rest of the code can stay the same. All right, try that. So try it. I know for some of you it's difficult, but
Wait, so which, I was going to use the average and the get there in the definition of the variance form. So what would we change?
Yeah. So you will need to first calculate the average
Yeah.
by
So we can use
by calling this or this,
Yeah.
whichever version you want to use.
Mhm.
All right. And then store it into a variable.
Yeah.
And then go into a loop that will calculate this.
Okay.
Right. So does that make sense? Hopefully that makes sense. So I guess there is kind of one skill here that is often taken for granted, but we should not. That is translation between mathematical notation and code.
Mm-hmm.
Okay, so actually, when you understand that translation, you actually understand this better. Actually, I find, right? Because I think, at least to me, the code is more intuitive. Outside folks, CIS folks should be. Sir? I think we're going to be working with matplotlib too. So you only need matplotlib.
Oh, in the data set. Because I'm using my real data set. Stupid.
Okay,
That's why I'm really stuck.
I won't look. I won't look. I won't look.
I forgot that we're supposed to be using our real data set. I have to run it in.
Okay. So looks like some of you are still struggling a little bit, which is normal. But let me actually try to do it as well. Oh, this is a little slow. So let me do def get variance. I'll just call data table instead. Do column ID and so okay. I'm going to do get average is equals to get average. I'm going to do version 2 and data table call and then I'm going to do the same trick.
Okay, I have to do
Kind of paste. Oops, but I changed the names, so I gotta go fix it. Alright, so now this is what I'm going to do. I'm going to put in a temporary variable. Deviation. Let me make it this. Those were all integers. Okay, that's fine. Minus the average. And then I can then just do deviation star deviation. Okay. And then the rest should be okay. It should be good. So let's actually then call this get variance, copy, oops, copy data. I was using column. This one was doing 1, and that's not put 2 here. So let me just put 2 there anyway. So we do this. Let me print that, and we'll go ahead and run it. Okay, so that's the variance. Again, for the especially for the CS folks, right? When I'm computing the variance this way, how many times did I look through the data? Sorry?
Yeah, however many values you had.
Yeah, but how many times did I go through the data? Like if my data has got, how many rows do I have? I think it was like 100,000 or something like that. Right? How many times did I go through the data? ICS folks, I'm not expecting the CIS folks to be able to answer this. Although you might be able to actually. How many times have I gone through the data? Twice.
That's for the average.
Yes.
And then again
Right. Because when I call get average version 2 here, I did one for loop going through the data once, right? And then after that, I went through the data a second time to calculate the deviation from the mean and squaring that. So I went through the data twice. Okay. So here's a question. Can I calculate variance by going through the data just once?
No.
Think about it. Think about it. Think about it.
They incorporate both average and variance in the same folder.
How? Because you do need to you do need the value of average here. Okay. Any ideas? Okay. The clue is look here.
Difference of squares.
Yeah. And down here, if you look at this formula, okay, you can actually compute this formula in one pass. Because, well, E of X, that's just your average, right? This is the average of squares, which you can compute in the same loop when you compute the average. Okay? So, something for you to explore yourself. I mean, for the computer science folks, this I hope is no-brainer. I mean, once you know to use this formula, right? Again, translate this back into code, right? Translating this back into code, you can combine the two loops, right? Again, right? You know, mapping this is to the for loop, and so on. All right. Again, that's just sort of for fun, if you will. The good news is this. The good news is that you don't need to write these yourself. So we've been doing this just for you to practice for loops. All right, thinking in terms of for loops. There's a bunch of libraries which provide a lot of these functionality. NumPy is one of them. NumPy it's a library that provides you with multi-dimensional arrays of this. So it's super useful, right? Right now, what we're using here, what we're using in our scripts here, you're just using regular Python arrays or Python lists, right? And we've stored the table in a list of this or an array of arrays, right? So there's a difference between sort of just plain old Python arrays versus NumPy arrays, right? But they are both interchangeable. Oftentimes, the the libraries that take a NumPy array will also take a regular Python array. All right. But the nice thing about the NumPy, so you can read about all the gory details, but is that it does have a statistics module. Where is that? I thought I linked directly to it, but maybe I did not. But there is a statistics module. Maybe docs. Complete. Maybe it's in the manual.
It's linked on that first page.
Oh, it is?
Other functions and methods
Thank you.
are like 2/3 of
Two-thirds of the way down. Tell me when I missed it.
the way. Okay.
Universal functions, okay. Maybe the fonts are too small. Let me get this bigger. Copies and views, deep copy.
There you go.
Ah, there you go. Basic statistics, yes, here you go. So, mean and variance, standard deviation, variance is all there. So good news is you don't really need to write those loops. But I made you do it just to practice for loops. Okay, you need to practice for loops on something that's relatively simple. Okay. Okay, so yeah, so mean you can just it just takes a regular array and it will actually compute the mean. So you could just use these. All right. So NumPy is a good library to know and to learn. All right. For Python and data science, it's almost like a required thing. All right. The other thing is, of course, we only have sort of the basic statistics stuff here. If you need something a bit more sophisticated, then you're going to go to, oh, here, I had NumPy statistics.
Yeah, it has the more complex ones.
Sorry.
Quantiles.
Yeah. So if you need the more complicated stuff, go to the SciPy statistics modules. All right. And there you have all the fancy stuff that you might need, like including generating random variates from normal distributions, from all sorts of strange distributions. So which means then that you could actually use that to do your statistical test or your hypothesis testing, because you need to compute p-values and whatnot. We'll talk about those later on, but again, SciPy would be where you can get a lot of this stuff, right? So distributions. If you want to plot the shape of a normal distribution over your data, you could again use this. Okay. So a lot of stuff here. All right. So we're not going to go through those today, but it's just sort of good to know kind of thing. So let's get back. Okay. So that's all I'm going to say about statistics for now, and for loops. Again, maybe as sort of for your own thing, try writing the for loop for that single pass variance algorithm, if you will, and see whether you can do it. But let's move on. All right. So next thing is actually plotting data. All right. And the standard module that's often used in Python is this module called matplotlib. All right. It's it's an extremely powerful module, if you will. All right. It has a lot of functions. You can plot almost anything with it. It doesn't necessarily mean it's going to be easy. But you can plot almost anything with it. I mean, you can click on the examples, for example, and then you can, and they will come with code, and you see that it can get pretty complicated. But that's often a good way to start. If I need to do a complicated plot, I would go to the examples and look for the closest thing to the one that I want, and then take the example code and try and modify it to fit my own specific situation. All right. So again, for plotting stuff, there's really two different purposes. One is just exploring data, and the other one is when you need to actually communicate results. All right. So so we are going to use matplotlib. What I'm going to say is that there are other tools out there. Obviously, there is R, and there's tools like Tableau, which also has a very strong plotting capabilities, and ton of other plotting tools. This is not the only one. Okay, this is not the only one. Some are easier to use, some are better for exploration, some are better for different things. But still, we're just going to learn this one, at least learn how to use it. Again, it's very complicated. I mean, it has lots of features, so we're not going to go through everything, but let's actually do at least something simple, right? And here you can fall back onto the book, and if you can see, it's to create a simple plot, it's pretty easy. Well, first you need this line to import the right library. So from matplotlib, you're importing pyplot. This as thing is a bit like a alias. Because remember, every time you call a function from a module, you sort of have to reference it by using the module name dot function call, right? And if the module name is kind of long, it gets a bit cumbersome. So the as sort of lets you create sort of like an alias. So you can do plt plot instead of pyplot dot plot, for example. So that's the easy stuff, if you will. So if you look at this, right, you basically put the look at this. You're putting the x-axis and the y-axis data, right, and you basically construct two arrays, right, one for the x-axis and one for the y-axis, right? So fairly standard stuff. Give it to pyplot, and these are just additional options that you can give it. And again, there's probably a lot more that you can look at the documentation for. Add a title. You can add the axis labels, and then plot show will actually bring this up. With one caveat, if you want it to show in, so let's actually do that. If you want it to show in your notebook, you need a inline directive, which I'm going to show you now. So it's a cell below. Let's insert one more. So let's see. I like to really see what I'm doing. So let's do that. Let's do that. So you can basically follow your book, if you will, and do the same thing as PLT. Right. So now just to make life easy. Oh wait, hang on. We need that directive, and it's percentage sign matplotlib. Hope I get this right. Oops. Lib inline. Right. Construct your X data, which I'm just going to grab the first column from the data, which is the ID column, and I'm going to grab the second column, which is the elevation column. I'm just going to plot that. All right. You can actually use a for loop to grab the first column. All right. But I'm going to show you this Pythonic way of doing it, which is using list comprehension. To me, it's just a very succinct way of writing a for loop, a simple for loop. All right. It doesn't matter if writing a for loop is easier for you, just do the for loop. All right. But this is a different way of writing a for loop. I would do row. So I'm going to take the first column of each row for row in copy data. All right. So that's a very succinct way of writing a for loop. Let me do the y data with no, I really want to do it like this. I want to be lazy.
Can you move the screen up?
Oh yeah. Oh, sorry. Thank you, Jasper.
You just
Yeah.
write it on the board.
Let me actually do this on top and this one below then, because you guys don't really need to see that one as much. Yeah. All right. For row in copy data. So this is equivalent to doing a for row in copy data colon within the for block would be what initialize y dot data to empty list for row in copy data y dot data dot append row square brackets 1. It's just a short. I think of it as a shorthand for that. Okay, so but it's just a very succinct way of doing of writing code actually. And then we're actually ready to actually do the plotting, right? So we can actually use the same command as the book, plt.plot, right? And I'm going to do x data, y data, color equals to green. I'm not going to do the marker, partly because I know I have about several thousand, 100,000 point lines, rows in the data, I'm sorry, and if I put in the marker, it's going to be really messy looking. But, okay, hit return. Let's add in the Y labels. And this is elevation. I think it's in meters. You can put in an X label if you want. This is just the ID. Alright, and then we can do plot.show. Okay. Now let's execute it and hopefully it executes. Wait, no, I didn't click it. Oh, there we go. So it's going to do the plot inline for you, and you can see it's a bit of a mess. So, why do you think this is so?
Why is it so messy?
Uh-huh.
Is there a lot?
Well, you got so many thousands of
Uh-huh.
rows, so it's putting them all row.
Uh-huh.
It's not showing the integration. So.
Yeah. Yeah, go ahead. Yeah, again, going back to the data, right? If you look at the head of the data, first column is just an ID. ID is probably something that's just arbitrarily assigned to each row, right? So you wouldn't expect any meaningful relationship between ID and elevation, all right? So it's okay that that's kind of messy and makes no sense. What you could do though is to actually
Like, what if you looked at like type of tree and elevation?
yeah, for example, would be nicer. But another thing to do then is also let's actually sort the elevation and just plot elevation. All right, you can just and then see and then you can sort of look at the again you're looking at the distribution of the elevation in your data set, right? So we could try and do that. And maybe what I'm going to do is I'm going to, let's see, can I duplicate a cell? Let's see. Not quite. Let's just do insert.
Just command A, command C, and then you can copy it down.
Oh, okay. Never mind.
This works.
um, so I'm going to copy this over, right? And then now the X data, again, I'm not going to plot the IDs anymore. So I'm actually going to get rid of this line. And so instead of the IDs, I just want the X data to be just 1, 2, 3, 4, 5 to however long it gets, all right? And there's a nice way to generate that in Python. It's called range 0, colon. I need the length of the data, which is the number of elements in the data, which you can get from the function length. So this is one way to do it. All right. So this will generate an array from 0 up to, but not including the number of elements in copy data. Okay. And then Y data, I really want to sort it, and I know we didn't go through sorting. Again, if you go to Python, oh, actually, it is in the book as well. There's actually 2 different functions for sorting. All right, and actually, you know what? Let's actually do the easy one, and then I'll show you the more complicated one. Because otherwise, I think you're going to freak out. Oh wait, where am I here? Yeah, let's do. Okay, but anyway, sort, S-O-R-T, will actually sort the array in place and modify that array. All right, so you could do that. But like I said, it's often safer and easier for debugging if you sort of make copies. I think the only exception to the rule is if the data is too big to fit in memory, then this is not going to be a good strategy. All right, but otherwise, so from debugging point of view, it's a good idea to make copies. So I can do Y data. Okay, I can still do the Y data, and then I can actually just sort it, right? I'm gonna do Y data sorted equals to sorted Y data, and actually I want it to be reverse sorted, so I think I can do reverse equals to true. All right, then here I'm going to do Y data sorted. All right. Okay, that's good. Oh, sorry, wrong syntax. I took the array syntax. Should be that. Okay. So that's your.
If my picture's not coming up, but it's running without any error, what do I need to do?
I think you just need to wait. Could be just slow, because mine took like 2 seconds before it popped up.
No, it's like 10.
Oh.
I did it.
Okay.
I'll ask you later. It's good.
Yeah.
The demon.
Yeah, I think your computer has issues.
It does.
Has issues. Okay, so this is the distribution. This is sort of a little. I guess maybe it's not surprising. Maybe it's sampling from a very smooth terrain, because this is elevation. Remember, we're looking at sort of a geographic thing. So you have sort of pretty smooth line. Otherwise, a lot of times you would expect something that looks more like a power distribution, where some values are very popular and many values are sort of not very frequent. Okay. Anyway, so this is how to sort. But I was going to say that I was going to show you something a little bit more complicated, right? So this one, I'm sorting a simple array because Y data is just a one-dimensional array. What if I want to sort the whole data set? Okay, what if I want to sort the whole data set? The whole table, right? But only on elevation. The sorting criteria is on elevation. How would I do that? All right. Go back to the documentation and take a quick look, and you're going to see this particular way of. So this is like what we wanted to do, right? You're going to use this construct, which I know is a little funky. Okay, and so let me actually okay. Well, let me actually do it in our code, and then we're going to explain that, right? So data is equals to okay, so there's a way to specify the key that you're going to sort the data on, all right, and you use this construct. The key equals, and lambda is, this is a special keyword. Again, this is the funky part. It's kind of pretty abstract. It's ability for you to write sort of one-time functions that's just going to be used here. So this is saying that key is going to be computed from this function, right? This unnamed anonymous function, which we introduce using lambda, and lambda is going to take as input the array. Let's see. Let me just call it that, right? And it's going to return you. What did we start it on? 1, yes. Elevation. Oops. Okay. And that's it. Let's see. I think that's it. Yes. Right. And if you do that, then this is going to be this will sort the whole. I'm sorry, I don't want to sort copy. Maybe I should have checked on me. Copy data is the entire data set. All right. So if you need to sort an entire array of array based on a particular column, this is the way that you're going to do it. All right, or one way that you're going to do it. All right. There are other ways that you can sort of do the same thing here. The using operator module functions, and which actually is a little bit cleaner. So you can try those out yourself. All right. Okay. So that should execute, but I didn't do anything with the data sorted, so you're not going to see anything interesting there. Oops. Let's minimize this. Okay. Oh no, this is the book. Where's mine? Okay, try. Okay, so next, right? We store data by decreasing elevation. Let's try maybe not plotting. Find the distribution of the forest cover labels. Okay, find the distribution of the forest cover labels. Let's not actually plot that yet, but let's just find the distribution. So oops. That's like level 2 hitting. Okay. So what does that mean? What does that mean? The forest cover labels, that's your that's the last column. Okay, that's the last column in this. Okay, it's this guy here. All right, and we know that the data only has like I think seven forest cover types. Right, so there's only 7 distinct labels. Right, so what do I need to do? Can you kind of operationalize it, especially in terms of a for loop?
So you do the array, and it'd be a negative, if you list the columns, you pull the negative, say, one would be the last column in that so-called array,
Okay,
you pull that data.
yeah,
Then you would actually look for the label of the distribution for us.
okay. How would you do that?
Are we trying to find just the count of the different types
Yes.
of forest covers, right?
Yes.
So you just want to count up each
You want
number.
to count up each label, yes. Good.
I know things, I just don't feel confident saying them out loud. Yeah, because you're just looking at how many of each cover you have. And
Yes.
You want to see if that what kind of distribution, meaning what kind of spread or does
Yes.
that look like? What's your variance and what's your
So that's the first step. You have to try and figure out what exactly you're trying to do, right? So how are we going to do that? We're going to, one way of doing that is I'm going to loop through the whole data set again. Or I can grab the column first, like what Jasper is suggesting, right? And maybe that's easier for you to conceptualize. So let's just grab the column first, right? And then loop through the column, right? And then what do I do?
Create a dictionary of counts.
Create a dictionary, right? I know we haven't talked about dictionary, but this is where I want to introduce the dictionary. All right. Think of dictionary as sort of like a lookup table, right? That's indexed by the forest cover. All right. So for each, so it's a key value pair. For each forest cover, I want to store a count. All right. If it's the first time I'm seeing it, I put 1. If it's if subsequent times that I've looked at cover, I want to increment that count by 1. All right. So again, you start with I want to find the counts of the different labels, and then you try to operationalize it in terms of a for loop. Okay. So again, if you have been looking at the book, right? I think it's still on the basics, right? So this is probably other than list, this is probably the other type of data structure you would probably ever need for Python. Most of the others, I really doubt that you'll deal much with them. But dictionaries are useful just as a lookup table, you know. Dictionaries are represented by curly braces, all right? And then, right? And you can address them by, again, square brackets with a key, all right? So which is really nice, all right? And then, in fact, here we have actually sample code that we could use already. So it's actually very similar to this for loop. This is counting the words in the document kind of thing. All
And
right.
so for our example, if we used copy data instead of document, we would be able to
Yeah.
be finding these counts of like types of tree or numbers. Or that
Correct.
Okay, cool.
Correct. That's exactly right. So again, this code example, you could almost use it directly. Pretty much. Just modify the different the variable names
Things
and
that you're looking
whatnot.
for.
Right.
And so for this example, if we were counting for types of cover, it would be, the word would be a number technically.
Yes.
Okay.
But it doesn't because the data set, if you remember, was actually all in strings.
Oh, yeah.
Yeah, until you actually convert it to number. So let's just try and do that. In fact, you can use the -1 indexing that Jasper suggested. But if you are curious, again, remember you can find the length of an array doing this. So I can actually take copy data, and I can take the first row, and that will give me the first row, right? And I can compute the length, and that would tell me the number of columns, right? And I know it's 56. So the last column is 1 less than that, so the last column is 55. So that's another way to do it. And then I can set my dictionary. So let's see. Let's do forest cover count equals to, I initially an empty dictionary, and then for row in copy data. All right. Now I'm going to do if row 55 is if row 55 in. So this is a construct where it's going to check all the keys of that dictionary. Then I'm going to set FCC NTS for its count.
You have one too many C's.
Oh yes, it's probably a bad variable name. Should put an underscore. Is equals to 1. Else, oh no, it doesn't do automatic. Else, FCCNTS, row 55 plus equals 1. And that's pretty much it. And you can print the whole dictionary. Oh, did I mess up? Oh, yeah, you're right. Thank you, guys.
Yeah, mine didn't work.
Yeah. Thank you for catching that.
Cool.
Okay, let's try it now. All right. So, now the reason why I didn't want you guys to plot is I already knew that the data set was completely uniform. So this was a well-constructed data set where each class has the same number of examples, which makes it very good for machine learning algorithms. Yeah. Anyway, so you don't need to plot this. You know how this looks already. Okay. But what if you were going to do this for another variable? What if you're going to do this for, say, I don't know, horizontal distance to hydrology?
Just change the row number.
We gotta know what row it is. I mean,
A column number, right? So it's
So let's say
0,
we-
1, 2, 3, 4. I mean, that would be the low-tech way of doing it.
Well, couldn't you list the, like, for row 1, take all those,
Yeah, you can.
and then from there, it basically, those are the columns
Yes.
itself?
Yes, you can do that. So
Change the name too.
So yeah, so I don't think that's a problem. We can deal with that. We can handle that, right? But say you look at this row, this column, you're likely to have many values, right? And even though it's an integer, but it's going to be likely to have too many values. So again, you would then actually want to do some form of binning, which again later on we can actually talk about that. But okay, but say we don't do that, right? We don't do that right now. Then actually, again, let me see, how much time do I have?
20 minutes.
It's so exciting. Once you get into the meat of this.
I know. Okay, let's see whether we want to go through with this. But anyway, it turns out that there is, wait, is it here or somewhere else? I think it's here. Oh, here, yeah. So in fact, there's a different way of doing this, right? And that's using the counter module from collections, which will actually do just what we did earlier. All right. So again, if that was too funky, don't freak out, right? There is always a simpler function that's going to help you do all of that. So you can actually take this and actually do this. In fact, you can use the same technique to do the labels, right? By actually doing this counter. Oh, in fact, this one would actually do the binning for you because you're doing sort of tens, deciles, right? Not quantiles, deciles, right? So we can actually do this, and then you can actually do a bar plot, right? You know what? It's not going to take too long. Let's actually try this. Let's go ahead and actually try this, right? And let's actually do that for the hydrology. So column 4. And since I didn't plot anything here, I'm just going to continue on here, right? And I'm going to do let's see. Hydro data equals to row 4 for row in copy data, and I'm gonna go ahead and from collections import counter.
We're gonna use deciles also.
Let's just stick with deciles for now, and let's see what happens. So decile is computed using a lambda function. If you see in the code here, it's using a lambda function. And it's sort of, by the way, this is, okay, oh yeah, okay, this is good. This allows me to explain what this is doing, which is good. Grade, I want to do one grade. Okay, let's just do distance. Call it something that makes sense. Distance. 10. So there's a integer division here, and oh, hang on. Let me actually cast this into an integer. That will make life a little bit easier. Because I believe those are all integers. Okay, and then you can do the histogram. Okay, so what this line is doing, it's creating a lambda function, and this is where things get again a little abstract, right? I'm assigning this function into decile. So decile is actually now a function. Okay. So another way to do this is to actually use a regular way of defining a function, def decile parenthesis dist colon, and then return this / this divided by 10 times 10. All right. So sometimes this can bother some people that there is more than one way of doing the same thing. It can drive some people nuts. All right. Why don't you just have one way of doing one thing? But some of us might like different ways of doing it. So I'll wait.
Hydro data.
Yeah. Distance. Again, see, this is list comprehension again. It's the shorthand for writing a for loop again, to actually create an array. So you're passing it to counter really an array, right? For this in hydro data. Hopefully we didn't screw up. But let's go ahead and plot the data. And I'm not sure if decile is the right, actually let's go back and take a quick look. Is decile the right? Decile might, well, let's try it. Right, so let's see. I'm not going to do the shifting of left by 4 because I don't think we need it. So let's just do histogram dot keys. This should give you all the all the x-axis values, and then histogram dot values. So again, it's in fact we should actually print histogram. Histogram is probably a dictionary-like data structure with a key and a value, right? And keys, when you do histogram.keys, it just grabs all the distinct keys that it has in a packaging in an array and returns that. Histogram values, again, packages all the values of the dictionary and returns that as an array. All right. So this then lets you construct your x-axis data and your y-axis data. And give a bar width. Let's see. Let's do the bar width. I'm not completely sure if 8 will work for us, but you just have to try it. Right. I'm just going to let the plot axis be default, and oops. And I'm just going to take defaults for the rest, actually. Maybe I will do the labels, but that's about it. Decile distance. Oh wait, no, that's Y. Oh no, that's X, that's sorry. That's Y label. Oops. And this would be number of rows. Yeah, let's see what happened. Oops.
Okay, mine did that. Oh, mine did it in a different place.
Let's see what happened. Object does not support indexing, really? Did I mess up here with histogram, counter? It doesn't do keys? Let me take a look. Oh, it's okay, keys and values.
Your decile is capitalized. Shouldn't it be lowercase?
Which one?
In the second next row.
This one?
Yeah.
No, that's a string. Should be
Oh,
okay.
shouldn't matter.
Let's see. It should work. Why not?
Because mine worked without all that extra stuff.
Yours worked?
Without those extra 3 lines, I just tried to plot it because I had messes up in the
Without these?
top. Yeah,
Without the labels?
yeah, it works.
That shouldn't make a difference, really.
Mine worked. And I have bars.
You got bars? Okay, let's do it.
I was not.
Yeah, mine doesn't like it.
But it's pointing to that level with the labels. That's where the arrow is pointing to up higher in the notebook.
What happened? Did I mess up something with histogram? Because the keys should work. Okay. So what I'm going to do is just...
You have an 8. Why do you have an 8 at the end of the values? I don't have that. Mine's working. Oh, that's just the width.
yeah, but I don't want to do the shift.
Try to take off the 8. Mine
Yeah,
doesn't
okay.
have that.
Yeah, I don't want to do the shift. The shifting, that's for that example. But
Try that.
let's try it. No harm.
No,
Nah, I figure not. So,
so mine worked.
huh.
And none of my other graphs have worked so far.
So when it works on yours, it doesn't work on mine.
Yep.
I think so too. I think so too. So I was going to try and print out and see what that type is actually. In fact, let's actually do this first.
You just use the debugger, that way you don't have to keep printing and rerunning stuff.
Let's see.
You still got histogram.
Oh, that's probably it. Yeah, you did.
Yeah.
Never mind, I thought you meant the other part.
Never done the debugger in Jupyter actually.
It works.
It works?
You can just do import PDB and then set a trace.
Okay.
Mm,
Okay, let me not do that right now. Class the keys. Okay, maybe that's why. Because it's expecting an array. It's expecting an array. So that's why. So we have a type mismatch. Okay. That's fine.
So why is it working for me?
Did you type the for x stuff? Because if you do that, it will convert it back into an array.
Yeah.
So I'm not sure about the. I'm just gonna do. Because it will iterate.
You could probably just cast it as a list, and just say list parentheses.
That's a good
histogram
point.
keys.
Let's do the cast and see. Otherwise, I could have done the list comprehension too, but just with a parenthesis. Oh wait, what happened? Did I run it? Okay.
There you go.
Ah, okay. So it runs. There's a lot of values, so the bars are extremely tiny. All right, so you could mess with the decile and make it, instead of 10, bins of 100 again. Again, I think there is a binning function within either numpy or scipy that will actually let you do that. Okay. Questions so far? Anything? Questions? Okay. Otherwise, let's see. A few more minutes. Let's see. Should okay. Okay. I'm going to introduce the next one, but I probably won't be able to get to it. What I would like to do next is actually to use the scikit-learn library. So this is a library that we are going to be using in this class as well. Right, and what we're going to do is we are going to run a decision tree algorithm on this data set. All right, and to actually create a decision trees. Again, if you do not know what a decision tree is, okay, anybody not know what a decision tree is? Okay, a decision tree is a, think of it as a tree where at each point you ask a question and then it splits, all right, into 2 or more outcomes. And at which point you ask another question and then it splits some more. And then once we have asked enough questions, the decision tree will then give you a label or a classification. So in this case, we have a data set where we're trying to predict the forest cover label, right? So if we create a decision tree for that, basically it's going to say that, oh, if first column is this value and second column is this value and third column is this value, then it is label 1 or it's label 2 and so on. So that's what a decision tree is. It's sort of relatively easy to understand, I think, for most people. Let me actually get to the documentation here. So scikit-learn is a machine learning or data mining library with a whole bunch of routines that you can use to learn models from data, all right? And like I said, I think decision tree is a very easy one that is easy to understand, all right? So that's what we're going to do next, right? And there is, okay, so this is an example of a decision tree that has been plotted, and we will try and plot this, right? At the top, it says petal length less than 2.45. If this is true, you go down this branch, and it says that the class is Setosa. Right? If it's false, you go down this branch and it says petal width is less than 1.75. If it's true, you go down this branch. If it's false, you go down this branch. Right? So each node, there is a question or a decision point. Right? And you keep going down until you hit a leaf node, in which case you get a decision. Right? Which in this case is a label. Okay? So you keep going down until you get, yeah, so the leaf nodes all have a class label, versicolor, class virginica, and so on. All right. So what we're going to do is we're going to run the algorithm to actually get this. Now, in order to visualize this tree, though, you do have to install a package called GraphViz. There's two things you need to install. You need to install the GraphViz program itself. Then you need to install the GraphViz Python package. So there's actually two different things. All right. And so again, I think after this class, if you can, try and install those two things: the GraphViz package, or the GraphViz program itself, and the GraphViz Python package. Okay. So the Python package is merely just an API that lets you call the GraphViz program. But the GraphViz is just a tree or graph plotting tool that will let you visualize the tree in this way. Okay? But going back to decision trees, right? So what's going to happen is that we have loaded the training data in our Python notebook. And typically what's going to happen is that all the scikit-learn modules function this way. You call a fit function, F-I-T. Think of like curve fitting. You're trying to fit a curve to data. So that's what you're doing. You're trying to fit a model to data. You call the fit function. The fit function is going to take your training data and it's going to fit a model to it. In this case, it's going to fit a decision tree model to it. All right. So the fit function will return you a model, and then you use the model. You can call the predict function. That will then, predict function will take as input a model and an example or examples, and it's going to actually apply the model onto the example to get the label. Okay, and all the scikit-learn functions are going to follow that same pattern, right? They all have a fit function for the training portion, and they have a predict function to do the prediction. Okay. So I'm going to stop here. So next class, and it wouldn't take long at all, maybe this next class just in 10-15 minutes, we're going to just finish this up. We're going to fit a decision tree model to this data, right? Take a look at it while visualizing the decision tree. Possibly just run it through a few examples to predict a few examples. And then we're just going to leave it as that. And that will sort of conclude our Python intro. I know it's kind of really a whirlwind intro in 2.5 classes. Okay, but I think you can pick it up, guys. I think you have enough that if we keep doing this, because we will keep using Python for subsequent classes, I will not be hand-holding you as much. All right, so these two classes, I'm sort of holding your hands a little bit more, but after this, you're more on your own. All right, but we will still be doing some Python in class. Okay? So any questions? Okay, if you are having trouble with Python, if you need some help, I'm definitely happy to help. So just set up an appointment with me or come to office hours or something. Okay? Okay, thank you guys. Thank you.
As I said, your point of view for listening and paying attention instead of just.
I have to go run my R data right now, but on Thursday I'm gonna come a little early and
Okay.
ask questions. And I think my computer was angry because I left it on for too long. Because I tried to like close it and it was telling me it was trying to do those things in the background.
Oh yeah, you let it finish first.
But it shouldn't take that long.
Wait, this is the Python stuff?
Yeah, like what we were just doing when I was trying to graph those first screen graphs. Like they worked last night when I was running through it, just practicing at home. And then when I was trying to run it this morning, it wouldn't. And so I shut it all down. And then we moved on to the histogram example. It worked. So I think it is, I'm getting a new computer. My mommy's helping me buy it, so I have to wait until I see her this week. And then we're gonna go do that. Dr. Souther sent me a bunch of specs to like pick from. It's ridiculous.